Good morning, everyone. I am Aarti KV, and today I am here to present a seminar on the topic Statistical Pattern Recognition. Computer vision aims to enable computers to understand and interpret visual data such as images or videos in a manner similar to human perception. Statistical pattern recognition provides a framework to extract relevant features, classify objects or scenes, detect and track objects, perform image segmentation, and solve various other computer vision tasks. The contents that are included in this presentation are pattern recognition, types of pattern recognition models, statistical pattern recognition, model of statistical pattern recognition, approaches in statistical pattern recognition, conclusion, and finally, references. Before looking at what is statistical pattern recognition, we need to understand what is a pattern. A pattern is everything around in this digital world. A pattern can either be seen physically or it can be observed mathematically by applying algorithms. For example, in our daily life around us, we see many patterns such as the colors on the clothes, the speech pattern, musical pattern, geographical patterns, etc. In computer science, a pattern is represented using vector feature values. So what is a feature? A feature may be represented as continuous discrete or discrete binary variables. A feature is a function of one or more measurements computed so that quantifies some significant characteristics of the object. That is, a feature is a function of a measurement that allows us to quantify a significant characteristics of an object. A set of features that are taken together forms the feature vector. For example, when we consider our face, the eyes, ears, nose, etc. are the features of the face. So when all these features are taken together in a sequence, it forms a feature vector. That is, when we take the eyes, ears, nose together, it forms a feature vector. This feature vector allows us to identify or differentiate each individual's face. Each individual's face is different from each other based on this feature vector. Next, what is pattern recognition? We have seen what is a pattern. Now, a pattern recognition is the process of recognizing pattern by using a machine learning algorithm. It is defined as classification of data based on knowledge already gained or on statistical information extracted from patterns and or their representations. The examples of pattern recognition include speech recognition, speech identification, multimedia document recognition, automatic medical diagnosis, etc. One of the important aspects of pattern recognition is its application potential. In a typical pattern recognition application, the raw data is processed and converted into a form that is amenable for a machine to use. A pattern recognition mainly involves classification and cluster of patterns. In classification, an appropriate class label is assigned to a pattern based on an abstraction that is generated using a set of training pattern or domain knowledge. That is, we apply a class label or we assign a class label to a pattern based on previous knowledge or based on the training patterns. Whereas in clustering, we generate partition of data which helps in decision making. That is, we partition the data to different clusters. Next, we can see various types of pattern recognition model. There are mainly three types of pattern recognition models: statistical pattern recognition, synthetic pattern recognition, and neural pattern recognition. In this presentation, we look mainly into the statistical pattern recognition. So, what is a statistical pattern recognition? Statistical pattern recognition is a term that is used to cover all phases of an investigation, from problem formulation and data collection through to discrimination and classification, assessment of results, and interpretation. That is, first we need to identify the problem, that is the problem formulation, and we collect the data that are related to the problem, and then we discriminate or classify the data, and from the classified results, we assess the result and we come into a conclusion or interpretations. The statistical pattern recognition are based on statistics and probabilities. Here, the features are converted into numbers which are placed into a vector to represent the pattern, and then various statistic and probabilistic techniques are applied to it. That is, we have already seen that we need a feature and a feature vector to recognize various patterns. So in statistical pattern recognition, we convert these features into various numbers that are placed into vector, and we apply the statistic and probabilistic technique to these feature vectors to identify the pattern. That is, statistical pattern recognition is to use statistics to learn from examples. The idea is to learn from examples with the help of statistics. It means to collect observations. So the first objective is to collect observations, study them and digest them in order to infer concepts. That is, we need to take some concepts or produce concepts that can be applied to new unseen observations or situations. We need to analyze some situations and take out some concepts and general views that can be applied to another unknown situation that we will be observing next time. Thus, the recognition is done by classifying the input into predefined categories. First, we classify the input into predefined category. So, whenever we get a similar kind of input next time, the machine is ready to treat them in right way. In this approach, each pattern is represented in terms of d features and is viewed in as a point in a d-dimensional space. Why d features and why d-dimensional space? Because to reduce the difference or to make a difference between two different patterns, we actually need a feature that makes a pattern different from its existing pattern. We need each feature to be different in each dimension. For a three dimension, we need three different features for a pattern to make it different from another pattern. That is why it is d features and d-dimensional space. For each dimension, we need at least one different feature of a particular pattern that makes a pattern different from another pattern. Here, the goal is to choose those features that allow pattern vector belonging to different categories and disjoint regions in a d-dimensional feature space. If we are given a set of training patterns, so from each class, the objective is to establish a decision boundary in feature space with separate pattern belonging to different classes. Or we can say that if we are having a data set, we need to decide the boundaries that help us to understand that a pattern is different from one another. So we need to make decision boundaries on a given training pattern and divide it into different categories or classes for later use. In statistical decision theoretic approach, the decision boundaries are determined by probability distribution. In statistical decision theoretic approach is that we come into a decision boundary with the help of probability distribution, or with the help of probability we come onto a conclusion, or we make a decision, or we decide the decision boundaries. Next we can see the model of statistical pattern recognition. The model is mainly divided into two major modes of operation, that is training and classification. In the diagram we can see the classification phase and the training phase. In the training phase, we provide the training pattern, and the major processes are preprocessing, feature extraction or selection, and learning. In the role of preprocessing module is to segment the pattern of interest from the background, remove noise, normalize the pattern, and any other operation we should contribute in defining a compact representation of the pattern. Then comes the feature extraction or selection. We extract the meaningful features from the data. In the learning mode, it learns from the extracted features. It finds the appropriate feature for representing the input pattern. After the training is completed, then comes the classification phase. Here we provide the test pattern, and the first phase is the pre-processing phase. Then comes the feature measurement phase. Here we see what are the different kinds of features present in the pattern, and then comes the classification phase, which is the ultimate goal. That is, we need to classify the given data into various classes or groups, so that whenever next time a new pattern comes, the machine is ready to treat them in the right way and classify it into the correct classes or groups. Next is the process in statistical pattern recognition. Statistical pattern recognition can be based on whether the decision boundaries are obtained directly geometric approach, or indirectly probabilistic density approach. The probabilistic density approach requires to estimate the density function first and then construct the discriminant function which specify the decision boundaries. Geometric approach often constructs the decision boundaries directly from optimizing certain cost functions. So in this diagram, we can see various approaches to statistical pattern recognition. Next is the applications of statistical pattern recognition. Statistical pattern recognition plays a vital role in various computer vision applications including image classification, object detection and tracking, facial recognition, gesture recognition, image recognition, and many more. It provides a foundation for automated visual understanding and enables computers to perceive and interpret visual information in a meaningful way. On concluding, we can say that statistical pattern recognition in computer vision is a powerful approach to automatically extract meaningful patterns and structures from visual data using statistical methods. Feature extraction identifies informative features for representing visual information. Statistical models capture underlying pattern to enable recognition and classification. Machine learning techniques enhance pattern recognition by learning from labeled training data. The applications of statistical pattern recognition in computer vision are diverse and continue to advance through ongoing research. These are the references that are made while making this presentation. So that is the end of the presentation. In this presentation, we have seen what is pattern recognition, various types of pattern recognition, statistical pattern recognition, model of statistical pattern recognition, approaches to statistical pattern recognition, and various applications of statistical pattern recognition. Thank you.